In this tutorial, I'm going to help you with balancing more complex equations. You may want to have a highlighter handy to help you with some of the equations. The first type of equation that we're going to balance is an equation with a polyatomic ion. Remember from our previous unit, a polyatomic ion is a group of atoms that are bonded together. They stay bonded together and you don't change their formula. So if we look at our first equation, OH3 is a polyatomic ion, and over here, this OH is also a polyatomic ion. I'm going to go ahead and highlight that because we're going to keep these grouped together. You don't have to separate them when you do your atom inventory. Down here, in our second equation, NH4 and OH and PO4 are all polyatomic ions. I'm going to highlight each of these because you can keep them all bundled together. You don't have to separate them when you do your balancing. Now we're going to go and balance just like we've done before, except you keep the polyatomic ions bundled together. So let's do our atom inventory. So you can see I've done the atom inventory for you. 1 aluminum, 3 OHs because the subscript on the outside distributes to everything on the inside of the parentheses. 1 hydrogen, 1 bromine. 1 aluminum, 3 bromine, 1 hydrogen, and just 1 OH on this side. So now we need to figure out which part of the equation looks the trickiest to balance. I'm going to start with the OH. So let's look at the OHs. Well, let's take a coefficient of 3 and multiply this side. Let's put this in a square because that's going to be your coefficient. We're going to put that up here in front of your compound. That's going to distribute to the OH and it's going to distribute to your H. So let's change your H because we put a coefficient, put it in a square, and that will equal 3. So now let's go back and let's balance our H's because our H's are now out of balance. So we're going to go back to this side. We have 1 over here. Multiply it by 3. That's your coefficient. I'm going to put it in a square. Put that in front of your compound with H. We don't want to put it over here because remember that's OH. That's bundled together, so it's got to go with the single hydrogen. That distributes to the hydrogen here. It also distributes to the bromine. So we're going to add our coefficient. Multiply that right there. 1 times 3 is 3. And we're going to check and see if we need to balance anything else. Aluminums are 1. OH, 3 and 3. H, 3 and 3. Bromine, 3 and 3. This equation is balanced. Let's try the next one. I want you to pause the video and complete your atom inventory. Alright, now that you're back with me, you should have your atom inventory and hopefully it matches up with what I've gotten. 1 NH4, 1 OH, 3 hydrogens, and 1 phosphate. 3 NH4s, 1 hydroxide, 1 hydrogen, and 1 phosphate. So we're going to find the trickiest one and start balancing with that. I'm going to start with the NH4s. On this side we only have 1, so I'm going to multiply that by 3. Put a square around that because that's your coefficient, and it goes in front of your compound. That distributes to everything inside the parentheses, and it distributes to everything over here. So we also have 3 OHs. Now, let's go balance your OHs. So we're going to go over here, go over to your OHs, and we're going to multiply this guy by 3. That becomes your coefficient. This distributes to the OH. It also distributes to the H. Multiply your H by 3. Put a square around it because that's your coefficient. Now let's go back and check. NH4, 3, and 3. OH, 3, and 3. H, 3, and 3. PO4, 1, and 1. You are balanced. And that's all there is to it. If you've gotten the hang of balancing, finish the second page of this worksheet on your own. If you would like to continue the tutorial, I will work out a few more problems for you. So on this page, we're going to start back from the beginning of balancing. In part A, I want you to identify the different parts of a formula. We're going to circle the subscripts and put a square around the coefficients. So in the first example, there is no coefficient, but we do have a subscript, so we're going to circle it. In the second one, we have the 2 is a coefficient, but there are no subscripts. In the next example, we have a coefficient and a subscript. And I'm going to label this with a C for coefficient and an S for subscript. You continue with the next 3 examples. Please pause the video and finish the next 3 examples before continuing. Please check your answers and make sure you circled the subscripts and put a square around the coefficients. In the next part B, we're going to do an atom inventory for each of the compounds. I'm not going to work through every single one. I'm just going to do the first 2. So in the first one, we have carbon and we have hydrogen. We have 2 carbons and we have 6 hydrogens. In the second example, the coefficient is going to distribute to each of your elements. So in this case, we have magnesium and oxygen. You have 2 magnesium and 2 oxygen. Pause the video and try the next 4 examples. Please check your work and see if you did the correct atom inventory. In part C, we're going to balance. You're going to show your atom inventory and then use coefficients in order to balance the equations. They've already given you the elements. You just have to write your answers. So let's do the first 2 together, and then you're going to go on your own. P1, O2, P4, O10. In this example, we're going to look for the one that looks the most tricky. I think I'm going to start with the oxygens in this case. So in order to balance these, I'm going to multiply my oxygen over here by 5. Put a square around this. That's your coefficient. And that goes up in front of your oxygen. I have 1 phosphorus and 4 over here. I'm going to multiply this one by 4. And I'm going to put my 4 over here. And now we've got 4, 10, 4, and 10. It is balanced. In the next example, we have 1 magnesium, 2 oxygen, 1 magnesium, and only 1 oxygen. So we need to start by balancing the oxygens. Let's put a coefficient of 2 in front of your compound. So it goes up here. But remember, that distributes. If it goes to the oxygen, it also goes to the magnesium. So we're going to multiply the magnesium by 2. So I've got to go back to my other side and balance out the magnesium. And that becomes 2 Mg plus O2. If you've gotten the hang of it, you can go ahead and work at your own pace. If you need another example, I will work through one more, and then you're going to work on your own. Mercury, 1. Oxygen, 1. Over here, mercury, 1. Oxygen, 2. So we're going to start with our oxygens, multiply it by 2, put a square around it because that's your coefficient. That has to go in front of your compound. If it distributes to the oxygen, it has to go to the mercury. So we're going to multiply mercury by 2. We've got to balance the other side now. So I'm going to multiply my mercury over here by 2 and put a coefficient in front of the mercury. Please pause the video and complete the final 2 problems on this side. In the final example, SO4 is a polyatomic ion. You can actually keep that all grouped together. So you can see I crossed out the S and the O individually and made that SO4. So you can count each of these as being 1 SO4. It will just make your balancing a little bit easier. So barium 1, chlorine 2, hydrogen 2, barium over here 1, chlorine 1, hydrogen 1. And now you can see where you need to do your balancing. And here are the last 2 equations on this side of the worksheet. Please do the back of this worksheet and then do the balancing equation challenge packet in order to prepare you for your balancing reaction quiz. If you need to go back and watch me do the equations again, please rewind the video and watch them again. Here is the correct atom inventory for the final page of the worksheet. These are not balanced, but you can check and make sure that you've counted the atoms correctly before you go and balance. I will not be balancing these for you. You must do these on your own.